power rule is really simple, but a lot of times we have to be a little bit creative in order to, I call this pre-write, in order to pre-write, thank you, in order to pre-write the equation or the function in such a way that we can apply the power rule, right? We looked at some examples where we turn radicals into powers, for example, stuff like that. Okay, what about a situation like this one where I've got multiple terms? What can we do? I got multiple terms and I've got a constant out front. Any ideas? When I take these derivatives, what do you think I can do here? Say that again. Yeah, okay, so what we say is I could pull the constant out front, right? So the -2, I can pull out in front, and then I could just differentiate term by term. Remember, differentiate means to take the derivative, right? And then I just take separate derivatives of each term. Okay, before I do that though, how do I probably want to rewrite that first function? I got to take this, and how do I need to rewrite that? 3x to what power? 1/3? -1/3. There you go. Good. I couldn't hear if people said that or not. Negative because it's on the bottom. 1/3 because it's a cube root. Okay, so then what am I going to get for the derivative of the first term? Jonathan, what am I getting for that if I differentiate that? Okay, x? Negative, right? Negative x to the -4/3. Give me thumbs on that. Does that make sense? Following the generalized power rule. We're just going to bring the exponent out in front, multiply by the coefficient, and then just subtract 1 from the exponent. Next term, Pagan, what do we get for this one? Oh, yeah, that's right. I shouldn't pick up. You weren't even here. That's right. Delube? I didn't think you were. Yeah. Abby? X cubed. There you go. And then the last one, derivative of 5, everybody? 0. Okay. So this is our answer. Then all I'd have to do is just redistribute that -2, right? And maybe I could write, like, let's just say they want this written in radical form, right? So then what would this become? If I distribute this, I'm going to get negative times negative is positive. I'm going to get a 2 on the top. And on the bottom, I'm going to get, how would I write x to the 4/3 on the bottom as a radical? What kind of root would it be? Cube root of x to the 4th. There you go. Okay, and then if I distribute over here, I'm going to get plus 56 x cubed. Okay, good. Questions? Yep. Yes, you betcha. Yep. Like that? Yep. Okay. These will be up there today too, I promise you. They'll be up on Plan Book today. In fact, I'll probably do it during lunch. Okay. Okay, how about this one? Find the derivative of f of x equals ax squared plus bx plus c. What are a, b, and c presumably here? What's kind of implied by this? They're constants, yeah. So Marie, what's going to be the derivative of that first term? 2ax. Bring the 2 out front. 2ax to the 1 plus, what's the derivative of bx? B. Good, because the derivative of x with respect to x is 1. Derivative of c is 0. Okay? Questions? Okay, find the equations of any horizontal tangents to the curve. Now this would have taken us a little while to do a week ago. We can do this really quickly now though, right? So what do we mean by horizontal tangents first of all? That's code for what? What's going on with a horizontal tangent line? Slope is 0. Yeah, okay. So horizontal tangents means that f prime equals 0, right? The slope is equal to 0. Okay, so all I'd have to do here is just differentiate the function and then set the derivative equal to 0 to find out the places where, the values of x where we have horizontal tangents, right? So what is the derivative of this one, Olivia? Minus 12, good. And we're going to set that equal to 0 and solve. So what do I get then? X equals, okay, x equals 2, doesn't it? Yep. So x equals 2. So those are the places where we have horizontal tangents. Okay, but we want to find the equation of the tangents, of the tangent lines, right? So we need a point and a slope. Okay, so what's my point then? If x is equal to 2, what's y equal to? Where would I go to find out? The function, good, right? So what's f of 2? Negative 8. Good. So I get the ordered pair 2, negative 8, and my slope is 0, right? So if I plug all this stuff into point slope, what do I get? Well, y minus negative 8 equals m, which is 0 times, who cares, x minus 2. But that whole side is just 0, so what's the line? Y equals negative 8. Which we knew it had to be. The horizontal line is y equals a constant, right? Okay. So do we really even have to go through the process of plugging information into point slope? No, probably not, right? Because we could have realized that if it's a horizontal line, oops.
All clear. Teachers and students, please resume business as usual.
Okay, I guess we're done there. So if it's a horizontal line, we know it has to be y equals whatever the y coordinate is for every point, including this point, right? So y equals negative 8. We could have just jumped right to that conclusion, right? Okay? Okay, I'll tell you what, why don't I'm going to save this stuff. I think this is all kind of optional stuff that I want to get to, but it's not so pressing for today.
Teachers and students, please resume business as usual.
We'll come back to this. In fact, maybe we'll even throw some of this stuff in there. That could even be kind of we could even maybe have another Friday football fun day or something coming up with some of that stuff. Okay, let's shift gears a little bit. I'm going to make a new